What happens when aerospace engineers apply modular design principles to something as simple as a frying pan? The result challenges every assumption about cookware storage and transforms kitchen organization from an exercise in frustration into a demonstration of precision engineering. The Culinary Tetris system represents a complete departure from traditional cookware thinking, replacing the chaotic jumble of mismatched pieces with 17 components that fit together with mathematical precision. The revolutionary concept behind this system starts with recognizing that traditional cookware design prioritizes individual piece functionality while completely ignoring how those pieces interact during storage. Aerospace modular design takes the opposite approach, engineering each component as part of a larger system where every piece must integrate seamlessly with others. This principle, typically reserved for spacecraft and aircraft components, creates cookware where storage efficiency becomes as important as cooking performance. The 17-piece configuration includes multiple pot sizes, pans, and accessories, yet the entire collection occupies less cabinet space than a traditional 6-piece set. This apparent contradiction stems from the stacking mechanism that eliminates wasted space between pieces. Traditional round-bottom pots create air gaps when stacked because their curved surfaces only contact each other at limited points. The Culinary Tetris system engineers specific geometric relationships between pieces, ensuring maximum surface contact and minimal air gaps during storage. Mathematical accuracy drives every dimension in the system. The largest stockpot serves as the foundation piece, with interior measurements calculated to accommodate the next smaller pot with precise clearance specifications. This pot-within-pot design continues down through multiple sizes, creating nested storage that resembles Russian dolls more than traditional cookware. The engineering tolerances maintain gaps measured in millimeters, tight enough to maximize space efficiency yet loose enough to allow easy separation when needed. Each piece incorporates subtle design modifications that enable perfect nesting without compromising cooking functionality. Bottom surfaces feature slightly tapered edges that guide proper alignment during stacking. Interior walls maintain consistent angles that allow nested pieces to sit securely without binding. The geometric precision extends to handle attachment points, lid fitment, and even spout positioning on specialized pieces, ensuring every element supports the modular storage concept. The modular handle system represents perhaps the most innovative departure from conventional cookware design. Rather than permanently attaching handles to individual pieces, the system employs a single removable handle that securely connects to any pot or pan in the collection. This handle features a precision-engineered locking mechanism that provides restaurant-grade security during cooking while releasing instantly for storage. The attachment points on each cookware piece maintain identical specifications, allowing one handle to serve the entire 17-piece collection. This handle innovation eliminates the storage nightmare created by traditional cookware where handles extend in different directions and prevent efficient stacking. With handles removed, every piece in the Culinary Tetris system presents a clean circular profile that enables perfect nesting. The single handle stores separately in a dedicated slot within the nested stack, adding no additional storage footprint to the system. How does the 17-piece Culinary Tetris set actually stack and store in a way that saves 60% more cabinet space? The answer lies in reimagining cookware as interlocking components rather than individual pieces competing for storage real estate. This engineering approach transforms the fundamental relationship between cooking capability and storage requirements, proving that comprehensive functionality and efficient organization can coexist through thoughtful design principles. The modular system demonstrates how aerospace engineering concepts can revolutionize everyday kitchen challenges. The smallest apartment kitchens in Tokyo somehow produce restaurant-quality meals. Here's their secret. These micro kitchens, often measuring just 6 feet by 4 feet, consistently output elaborate multi-course dinners that would challenge much larger American kitchen spaces. The difference isn't in cooking skill or ingredient quality, but in how space constraints force innovative approaches to equipment selection and storage. Japanese apartment dwellers have mastered the art of maximum functionality within minimum footprint, and modular cookware systems form the foundation of their success. Space limitations create powerful incentives for innovation that abundance never generates. When every square inch carries premium value, traditional cookware's wasteful storage patterns become economically impossible. Tokyo residents paying $3,000 monthly for 400 square feet cannot afford to dedicate multiple cabinets to poorly organized pots and pans. This economic pressure drives adoption of solutions that optimize functionality per cubic foot rather than simply maximizing total functionality. Traditional cooking wisdom suggests that different cooking styles require different specialized equipment taking up permanent positions in the kitchen. The modular system challenges this assumption by adapting to various cooking techniques without requiring dedicated counter real estate for each function. A single modular pot transforms from pasta boiler to stock pot to steamer depending on the attached accessories and cooking method. The system eliminates the need for specialized single-purpose equipment that sits unused between infrequent applications. The adaptation extends beyond basic cooking functions to accommodate accommodate cultural cooking styles that traditionally demand extensive equipment arrays. Asian stir-frying, which typically requires multiple woks of different sizes, works efficiently with modular pans that nest for storage but provide identical heat distribution characteristics during cooking. French technique heavy cooking, often requiring numerous specialized saucepans, operates smoothly with modular pieces that offer precise temperature control across multiple sizes while storing in minimal space. Studio apartment dwellers represent the most demanding test environment for space-efficient cookware systems. These living spaces typically allocate less than 12 square feet for kitchen functions, including storage, preparation, and cooking areas. Traditional cookware sets require storage space that exceeds the total kitchen footprint in many studio configurations. The modular system transforms these impossibly constrained spaces into functional cooking environments by reducing storage requirements from multiple cabinets to single compact areas. Reduced clutter generates unexpected improvements in cooking efficiency that extend beyond simple organization benefits. Clean counter spaces enable faster food preparation by eliminating the need to move equipment before starting work. Cooks can focus entirely on ingredient preparation and cooking technique rather than constantly managing workspace logistics. The mental energy previously devoted to navigating cluttered spaces becomes available for creative cooking decisions and technique refinement. One removable component eliminates the need for dozens of handles cluttering your cabinets. Traditional cookware sets burden homeowners with individual handles attached to every single piece, creating storage nightmares where protruding grips prevent efficient stacking and waste enormous amounts of cabinet space. The removable handle concept transforms this fundamental design flaw by engineering one precision-crafted handle that securely attaches to any piece in the entire cookware collection, instantly eliminating storage chaos while dramatically expanding cooking versatility. The removable handle revolution challenges assumptions that have dominated cookware design for over a century. Every cook accepts as normal that pots and pans arrive with permanently attached handles, despite the obvious storage problems this creates. These fixed handles serve only one function during the brief moments when someone actively cooks with that specific piece, yet they occupy cabinet space continuously and prevent efficient organization 24 hours daily. The removable system questions why handles should claim permanent real estate when they perform useful work for perhaps 30 minutes weekly per piece. Traditional cookware manufacturers perpetuate handle attachment methods that prioritize manufacturing convenience over user experience. Welding, riveting, or screwing handles directly onto cookware creates permanent connections that cannot adapt to changing cooking needs or storage constraints. These fixed attachments represent engineering laziness rather than thoughtful design, forcing consumers to accommodate wasteful storage patterns instead of creating products that work efficiently within real kitchen spaces. The locking mechanism itself employs a sophisticated cam lever system that creates multiple contact points between the handle and cookware attachment fixture. This distributed load design prevents stress concentration that could cause failure during heavy-duty cooking applications. The mechanical advantage provided by the cam lever allows users to achieve secure connections with minimal effort while ensuring the lock cannot accidentally release during cooking motions. Spring-loaded safety features provide tactile and audible confirmation when proper connection occurs.